Hi all, in today's video we're going to be finishing off quadratics, and the last part is looking at the discriminant, which helps us work out the nature of the roots, and I'll explain what that means. Okay, so previously we've just looked at the quadratic formula, okay, and the quadratic formula is given below in this box here, okay, so that should be familiar with us. And the discriminant has been part of that. Okay, so in particular, what we're going to focus on is the b squared minus 4ac part. Okay, so the b squared minus 4ac part, this is referred to as a discriminant. Okay, and I'll explain what in fact that does. Okay, so we know the quadratic formula gets us solutions to a quadratic equation. Okay, so solutions we get when we solve a quadratic equation using the quadratic formula or by factorizing is referred to the roots of the equation. Okay, what the discriminant does, which is the b squared minus 4ac part, that can very quickly tell us how many roots we expect to find. Okay, and it also tells us how many times a graph will indeed cut the x-axis as well. Okay, which will then in turn still tell us how many times it would cut the x-axis. Okay, and tell us how many roots we'll get. Okay, so before we even need to find an answer for the roots, we can work out quickly what type of roots we expect to have. Okay, so when thinking of quadratics, we actually have three possible scenarios. Okay, so we're looking at case one just now. So if we work out the discriminant, which is the b squared minus 4ac part, and see we get an answer for that part which is greater than 0, then what that tells us is we're going to have two real and distinct roots. Okay, distinct means that they're going to be different from each other. Okay, so we're going to have two real roots and they're going to be different from each other. Okay, and what that would look like as a graph would be one of the two situations here. So if it was a curve, a quadratic or a parabola that had a minimum turning point, it would look like the one on the left where it would come down, turn and go up, and you'd see it cuts at 2 points. Okay, I've highlighted that in the red bit there. Okay, so those bits there would be the roots. Okay, and I'll have another root there as well. Okay, and similarly over here we would have a maximum turning point. That could be another picture we have. However, if the discriminant is still bigger than 0, we would have one root there and we would have another root there. Okay, so we would end up with two real and distinct roots different from each other. Okay, so that's the first case, is if it's greater than 0, we end up with two real and distinct roots. Okay, if we work out the discriminant, so b squared minus 4ac, and we get the answer to be equal to 0, okay, then that's a second case. Okay, that means we have two real but equal roots. Okay, they are equal to each other. Okay, so you'll see here on my examples of what that would look like. It means the curve would come down, turn and go back up, but it would turn on the x-axis. Okay, or if it was a maximum turning point, it would come up, turn, go back down, and again it would turn on the x-axis. Okay, so when doing the quadratic formula or when factorizing, you would get two answers, but your answers would be the same as each other, they're equal to each other. Okay, but we still say they're two real roots, but they are equal in this case. Okay, so two real and equal roots there. Okay, and finally we have the last case when it is less than 0. So if we calculate b squared minus 4ac and it is less than 0, then we get no real roots. That's the answer. Now, the key thing is here, folks, that when we say this, we do specify no real roots. Okay, there are technically roots, however, they are not real roots. It's something you might see if you ever get to advanced higher, where they do have roots. You can calculate roots. Okay, but for us, it's fine enough for us to say no real roots, but you must say the word real in there. Okay, so we have no real roots. And you can see what that would look like as a picture, as my curve would come down and go up, and it wouldn't touch the x-axis, so we wouldn't have a root. Or if it was a maximum turning point, it would go up, come down, and it wouldn't touch the x-axis there either. Okay, so therefore it wouldn't have a root, no real roots. Okay, so there are the three scenarios we can get. What we often want to know sometimes about a quadratic equation is, does it have roots, and if so, what type of roots? So even before we calculate it, is can we work out what the type of roots we're going to get? What are the nature of the roots? Do we have two real roots that are distinct? Do we have two real roots that are equal? Or do we have no real roots with our question? Okay, we're going to look at a few examples doing that. Okay, so if we head into our notes, okay, so section 9.2.b, there's two examples here that we're going to go over. Okay, and there's a bit of a description of what I've just talked about above in bullet points there. Okay, so if it's greater than 0, we say two real distinct roots. Okay, if the quadratic is equals 0, two equal real roots, and if it's less than 0, then it has no real roots. Again, using that word real, using the word real in there. Okay, so let's show you how we do this. Okay, so it's very similar to the starting process of working out a question using the quadratic formula. Okay, first thing we do is we need to get our a, b, and c values like we did. So a is the number in front of the x squared. That's going to be 3. B, that's going to be 2 for me in this example, and c is going to be 1. Okay, so that's my starting off point. And then, like the quadratic formula, the first step we do is do b squared minus 4ac, but that's all we need to do at this point because we're asked here for the nature. Okay, and the nature just means is what type of roots we're going to get, not what they are, just what type we're going to get. Okay, so b squared minus 4ac. Okay, substituting these numbers in properly, that's going to give me 2 squared minus, remember we use our brackets, 4 times a, which is 3, times by 1, which is c. Okay, so 2 squared, that's 4, take away 4 times 3 is 12, times 1 is still 12, 4 take away 12, that gives me, I'm just going to give myself a little bit extra space here folks, and that gives me negative 8. Now I'm not interested too much in the fact that it's negative 8, all I'm really interested in is that I know it's negative, therefore it is less than 0. Okay, so I'm in the situation where b squared minus 4ac gave me an answer that was less than 0. So what I can say about this quadratic equation is that there are, I'm going to give myself a bit more space, that's it. Okay, so there are no real roots. That's the situation we were in. Okay, so remember we use the word real. Okay, there are no real roots because our answer was less than 0. Okay, and if I go back up to this bit here, you'll see the last bullet point tells me if it was less than 0, no real roots. Okay, so it's as simple as that regarding the working. Okay, there's not a lot of working involved. It's just asking you, can you then use your answer to justify what type of roots we're going to get. Okay, we'll look at the second example now, and you'll see the working is very similar again. So I need to then get my a, b, and c values. So a is going to be 9, b is going to be negative 12, and c is going to equal negative 24. Now you'll be able to tell that their negatives are vitally important here folks, because if you don't pick up on the negatives you might get a totally different answer which will give you the wrong type of roots. Okay, so do be careful with that there. So b squared minus 4ac. Now be careful with your numbers here folks, so b is negative 12, so I've got to make sure it's negative 12 squared. Take away 4 times a, that is 9, times c, which is negative 24. Okay, negative 12 squared, well the fact that we square negative means that we get a positive, so that's going to be 144. Take away 4 times 9, okay, that gives me 36, and if I times that by negative 24, I get negative 864. Okay, so this would be a question that you would be allowed a calculator for. Okay, remember two negatives combine, okay, when they're next to each other to make it a positive, so we're going to add these two together. That would give me 1008. However, all I'm really interested in the fact is this number is greater than 0. Okay, so I am now in a situation where my answer is greater than 0. Okay, so the answer means that if it's greater than 0, it means I have two real and distinct roots. So we just have to say that there are two real and distinct roots. Okay, and that's the final part of that question. Okay, so you can see these questions can be quite quick, and the working is not that much regarding other things we've seen. However, negatives are vital. Okay, make a mistake with negatives, it can cost you. And remember to always explain what your answer is properly. Okay, use the proper words that they use. Okay, because it's very easy to lose marks if they don't quite say it how we did. For example, if I just said in example 1 that there were no roots, I wouldn't get the mark. Okay, I need to say there's no real roots. Okay, so you've got to be really specific with that. Okay, but there's two examples on using the discriminant to work out what type of roots a quadratic would have. Okay folks, thank you.